Hello and welcome to this video where I will show you a step-by-step guide to creating another complete ESP32 project. In this video we will develop the code to measure the ambient temperature and humidity and display them on an OLED display. Let's take a look at what we'll be covering. The aims of the project are to measure the temperature and humidity using an AHT10 sensor, to show the measured values on an OLED display, and to demonstrate how to use the I2C_master.h I2C function wrapper. If you find this video useful, please press the like button and subscribe to the channel. These things are free for you and they really do help the channel develop. Now a word about my development environment. I have developed this using the ESP32 Dev Kit V1 module. Please check your pinouts if you're using a different ESP32 variant. Also note that the solution presented in this video will only work with ESP-IDF version 5.1 or later. The component block diagram shows how the I2C components are wired. The ESP32 is the I2C master and the OLED display and AHT10 devices are slave devices. The VCC pins on the OLED and AHT10 devices are wired to the 3v3 pin of the ESP32. The SDA pins are connected to D21 GPIO21 pin of the ESP32 and the SCL pins are connected to the D22 GPIO22 pin of the ESP32. The code presented here uses a previous project's code as a template. If you have been following my videos, you should have this project already. If not, then please check the links below. By becoming a member of Patreon, you will support the channel and gain full access to the source code developed here and in all my current and future videos. We will base this project on the previous I2C_scan project which we developed in a previous video, link to which is in the description below. Copy this baseline project and rename the folder AHT10_OLED. Now open VSCode and using File, Open Folder, open the AHT10_OLED folder. The first thing we need to do is install an OLED display driver from the Expressive Component Registry. Open the ESP-IDF Welcome tab. In this tab, click the Components Manager button. This opens the Expressive Components Registry. In the registry search box, enter ESP_SSD1306 and click the search button. The component we're wanting to install is KOI05 ESP_SSD1316. This component is the SSD1306 OLED driver and is built around the I2C_master.h, which wraps low-level OLED functions. Click the Install button to install into VSCode. Once installed, you will see there are two new folders under Managed_Components folder, K0I05 ESP SSD1306 and K0I05 ESP type utils. In addition, the dependency K0I05/ESP_SSD1306 has been added to the project manifest file IDF_component YAML. Now let's make changes to the source code. Open the main.c file. Add the line #include SSD1306.h to reference the ESP_SSD1306 definitions. Now change the tag value to something meaningful for this project. app_tag equals AHT10. Now let's add the device I2C address definitions. The OLED display has address hexadecimal 3C and the AHT10 has the address hexadecimal 38. Change the I2C underscore master underscore bus underscore handle underscore T variable to I2C0 underscore bus underscore handle. In the I2C underscore init method, add the ESP error check around the call to I2C underscore new underscore master underscore bus. Don't forget to change the name of the master bus handle. Now add the I2C underscore cleanup method. Now we add the OLED device handle, SSD1306 underscore handle underscore T, OLED underscore dev underscore handle. Now we add methods for initializing the OLED device. The method OLED underscore init initializes a new slave device on the specified master bus using the method SSD1306 underscore init. After the OLED device is initialized, the text "Please wait" is displayed on the OLED display. We now add methods to display the temperature and humidity on the OLED display. The methods format the float values and show on the display using the SSD1306 underscore display underscore text using the OLED device handle. Note that in the OLED underscore print underscore temperature method, the degree symbol is represented by the escape sequence \xb0. We now turn to adding methods for interacting with the AHT sensor. Create a static handle AHT10 underscore handle of type I2C underscore master underscore dev underscore handle underscore T for the AHT device. The first method is AHT10 underscore init, which registers the slave device handle on the master bus by a call to I2C underscore master underscore bus underscore add underscore device. Once the device handle is created, we send an initialization command to the AHT10 device using I2C underscore master underscore transmit. Also add the AHT10 underscore soft underscore reset method, which can be used to perform a soft reset of the device if required. We now add the method to read the temperature and humidity data from the AHT10 device. We start the measurement process by sending a trigger command. The method includes a for loop and error handling to make the reading of the measurements more robust. Add the code to extract the raw temperature and humidity measurements from the data returned by the AHT10 read command. Add the method AHT10 underscore read underscore vals to read and display the AHT10 temperature and humidity values. In the app underscore main method, add the method calls to initialize the I2C master bus, the OLED display, and the AHT sensor. After initializing the devices, add a short delay to allow devices to stabilize. In the while loop, call the method to read the AHT temperature and humidity values. The vtask delay method adds a delay at the end of the loop before the next read of the AHT10 sensor. Now let's build the project. On the ESP-IDF status bar, click the Build button. Building the project from scratch can take several minutes. After the build completes, click the Flash Device button on the ESP-IDF status bar. I am flashing to port COM3 using the Silicon Labs USB to UART driver. After flashing the ESP32 device, click the Monitor button on the ESP-IDF status bar. You will see in the monitor trace the temperature and humidity values read from the AHT sensor. These are the temperature and humidity values shown on the OLED display. Here are some exercises for you to try out. They are intended to help you apply what you've learned and to encourage you to research solutions. I suggest you use this project as a basis and make any changes accordingly. Exercises 2 and 3 will form the subjects of future videos. Well, that just about wraps up this tutorial. I hope that you found this video useful and that your project works successfully. I also hope that you'll consider pressing the like button and subscribing to the channel. These things are free for you and they really do help the channel develop. If you have any specific ESP32 development project ideas you'd like me to cover, then please place them in the comments. I will be posting more videos on ESP32 development regularly. And if you'd like access to the source code and circuit designs, then why not become a channel Patreon member? Please see the link in the description. Thank you for watching and bye for now.